Hello everyone. Let's continue learning about the basic classes in Java. Now, we'll study the third part, which is about math-related classes, math and random. Our objectives are to understand the methods related to mathematical operations, and to be able to generate random numbers. Let's start by taking a brief look at the math class. The math class is a mathematical operations class that provides a series of static methods for mathematical operations, including absolute values, trigonometric functions, and more. It has two static constants. One is pi, and the other is e. The constant e represents the base of the natural logarithm. Now, let's go through some methods of the math class. First, let's focus on the ABS method. This method is used to calculate the absolute value, returning the absolute value of the given parameter. If you pass an integer, the result will also be an integer. If you pass a floating point number, the result will be a floating point number. This ABS method is an overloaded method, meaning it can take parameters of multiple types. Next, let's look at the round method. This method performs typical rounding, returning an integer value. There are two more commonly used methods: ceil, floor, ceil, and floor. Ceil means ceiling, representing rounding up to the nearest integer. Floor represents rounding down to the nearest integer. Please remember these two methods. Let's take another look at our random method. The random method in math is used to generate random numbers. What is the range of these random numbers? It is a double type number, greater than or equal to 0 and less than 1. In other words, it is a number between 0 and 1. Now, let's examine the power method. This method is used to calculate the power of a number. For example, if we want to calculate 4 to the power of 2, the result would be 16. It's important to note that the return value is a double type. Moving on. Math, it represents the base of natural logarithms. And math, pi represents the value of pi. Next, there is another method called XP. This method is used to calculate the exponential value of the natural logarithm of e, which means e to the power of x. QRT. Let's now take a look at the squared method. This method is used to calculate the square root of a number, and it's a commonly used function. Now, let's discuss the two methods below, which are used to calculate logarithms without any additional parameters. It calculates the natural logarithm with base e. If you provide the base, like 10 in log 10, it calculates the logarithm of the given number with base 10. For example, log 10 with a parameter of 100 would result in the logarithm of 100 with base 10, which is 2. Next, we have min and max. These methods are used to find the minimum and maximum values between two numbers. They are also overloaded methods, meaning they can handle different types of arguments and return the corresponding value type. Lastly, there are two methods of degrees and radians. These methods are used to convert between radians and degrees. Moving on to the next page, we have the topic of trigonometric functions, such as sine, cosine, tangent, and inverse tangent, among others. If you haven't applied these functions in your calculations before, you can temporarily skip studying them for now. Just try to get a basic understanding. Now, let's take a look at the random class. As the name suggests, this class is used for generating random numbers. However, it's essential to note that the random numbers produced by this class are called pseudo-random. What does pseudo-random mean? It means that these random numbers are generated based on a seed value. If the seed value remains the same, the sequence of random numbers generated will also remain the same. In other words, the random sequence is determined by the seed value, making it a pseudo-random sequence. Now, let's explore the constructors of this class. The first constructor has no parameters. and its seed is set to the current system time. If you provide a seed value as a parameter, the random number sequence will be the same every time you use that specific seed value. Therefore, we call it a pseudo-random number sequence. So, when you encounter situations like computer-generated lotteries or random events, you may want to verify if they are truly random or based on pseudo-random sequences. Next, let's take a look at what kinds of random numbers this random class can generate. It can produce the following random values: random Boolean values, random byte values stored in a byte array, random double and float values, random double values following a Gaussian normal distribution, random integer and long integer values, ability to set the seed for the generator. Among these options, the nextInt method is commonly used. This method takes an integer as a parameter and generates a random integer between 0, inclusive, and n, exclusive, meaning n is not included in the range, but 0 is. Once we familiarize ourselves with this class, we can understand the meaning behind the code snippets provided. For example, ABS is used to calculate the absolute value. Max is used to find the maximum value between two numbers, and a 2 is less than 2 checks which is smaller between a 2 and 2. The code 2 to the power of 3 calculates 2 to the power of 3, and the random number generation code produces a random number. The sqrt4 calculates the square root of 4, and pi outputs the value of pi. Based on the analysis above, reading this code is very simple. Now, let's focus on the code on the right side. It involves trigonometric calculations. You can combine your previously learned mathematical knowledge to verify the correctness of the output. If you are not familiar with these trigonometric calculations, you can temporarily disregard them. Now, let's take a look at the second example. It requires us to generate a random integer between 50 and 100. We can achieve this using the methods of the math class or the random class. Let's use the random class to implement it. To analyze how we can generate a number between 50 and 100 with random fluctuations, we need to determine the range of random fluctuations first. The range should be 50, which corresponds to the interval between 50 and 100. To achieve this, we can generate a random number between 0 and 50, and then add it to 50. In this case, the random fluctuation amplitude is 50, and our starting point is not 0, but 50. So, to generate the random number, we need to be aware of the starting point, 50, and the range, 50, of the fluctuations. Once we have this information, generating the desired random number becomes straightforward. Let's implement it now. We are going to use the random class for this task. We'll create an object of the random class. And if we don't provide a seed value, it will use the current system time as the seed. Now, we'll generate random numbers and test the range of these numbers using a loop. For example, we'll use the nextInt method to generate random numbers between 0 and 10 and see if the results are correct. It's crucial to print the output to check the 10 random numbers generated. Initially, we might not see the number 0, but if we generate more random numbers, we will eventually get a 0. As we can observe, the generated random numbers are between 0 and 10, but do not include 10. There is no random number equal to 10 in the result. Similarly, when we analyzed earlier, we wanted to generate random numbers between. We should analyze that the starting value is 50, and the amplitude is also 50. Thus, when generating the random number, we need to add 50 to the random number between 0 and 50. Let's try to verify whether the requirements are met. As you can see, the generated numbers are indeed between 50 and 100. There is no occurrence of 50 or 100 in the output. Because there are too many numbers when we test, we can add a space to them and have it display 10 numbers per line. Let's take a look. Do we have 50 numbers here? How about 100? No, they are all two-digit numbers. That indicates that the range of numbers we generated is correct, and there are no numbers below 50. You can try this multiple times at this point. Also, here we can insert a line break before outputting. So everyone can see the result clearly. For testing random numbers, it's a good practice to put the generation code inside a loop. This way, you can generate multiple random numbers and easily verify whether they fall within the desired range. With this, we have covered the math and random classes today. Thank you. In Java, there are methods available to generate random numbers for various data types. The math random method can generate random numbers of the data type